So this one says at 60 degrees Fahrenheit, insects chirp at 63 times per minute. So guess what? That's 60, comma 63. So the implication is that the temperature has an impact on the chirps. How do I know that? Because the very next line says at 65 degrees Fahrenheit, they chirp 73 times per minute. So we're going to say 65, comma 73. And it says write an equation of a line. Well, if I have 2 points that will be on the line, I can find the equation of the line. In other words, if I label this as x sub 1, y sub 1, and I label this one as x sub 2, y sub 2, I can find out what the slope is. So remember, the formula for slope is y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. Now be careful here because there's 2 common mistakes, actually 3. Sometimes kids don't write the formula down. They put the x's on the top and the y's on the bottom. Sometimes kids don't pay attention to which number goes with which, and they put them in the wrong spot. The other common mistake is the formula has a negative sign, so if one of these is negative, they forget to minus the negative, which is really plus. But let's plug these in. Y sub 2 equals 73 minus y sub 1, which is 63, all over x sub 2, which is 65, minus x sub 1, which is 60. If you do the math, I've got 10 over 5. What's 10 over 5 reduced down to? 2. So that's the slope. So remember, I'm going to write an equation that's y equals mx plus b. And in order to do that, I need to know what m is, and I need to know what b is. So to find b, the process for finding b is pretty simple. I'm going to take an x and y value. It doesn't matter which one. I'm going to use the second one. And so I start off with y equals mx plus b. I've got most of these except for b. It doesn't matter which one. So I'm going to plug this in for x and plug this in for y. So I'm going to say 73 is equal to m, which is 2, times 65 plus b. 2 times 65 is 130 plus b. Now what do I do to get b by itself? Yes. Yep, I'm going to subtract 130 from both sides. Now that can be kind of hard, so I'm just going to use, it's not really hard, but we need to be proficient with our time because you're going to take a standardized test. So anyways, it's negative 57. Equals b. So now that I know what b is and now that I know what m is, I'm just going to say y equals m, which is 2 times x minus 57.
What is x for?
Well, x, so we haven't really talked about this a whole lot, but this is a function, and the function is like a machine. So when I say 2x minus 57, that's the function. So I'm going to plug in an input, and x is our input. And then it's going to spit out a y value, and our y value is our output. So it's an equation. We plug in. In other words, we wrote this equation. So now that I have the equation, how many chirps does a cricket do if the temperature is 90 degrees? Well, we plug it into the equation, and it tells us. How many chirps does it do if it's 82 degrees? We plug 82 in for x, and it tells us. That's the whole point of this. In the real world, when we use this math, what we do is we collect a bunch of data. We find 2 points on a line sometimes, and we make an equation that helps us to make predictions. So when you go to the store and you go to buy a shirt, and you go, wow, that's a cool shirt. You ever notice when you go to buy a shirt, there's like 1 in your size or maybe 2 in your size? That's because the stores know exactly how many shirts to keep on the rack. Always. And it's usually a simple equation like this. I did some research at Notre Dame for very complex research. but it had to do with thermal rectifiers, and this was for the Department of Aerospace and Mechanical Engineering. And I collected a bunch of data on thermal conductivity of carbon um, nanotubes, which sounds really fancy. Guess what type of equation I used? A linear equation. It was just a linear equation. And how did I create the linear equation? Well, essentially doing what I'm teaching you right now. That created a graph, and we could make predictions. What happens to the thermal conductivity of this carbon nanotube when the temperature gets such and such? Does that make sense? Probably doesn't make sense, but I mean, and I could show you that actually. Let me show you that. We'll keep it in the video too. So, RET, thermal rectifier. And so I'm going to zoom in. So this is some research that Mr. Adams did at the University of Notre Dame. And I just want to show you this real quick. This is, so I did a bunch of fancy research. What do you notice about these equations? This is saying, this right here is saying, look at that. It's saying that the thermal conductivity, what is that? Negative 0.00, or I'm sorry, 0.003 times T plus 1.169. Doesn't that look like a linear equation? Where the T stands for temperature. So the thermal conductivity of this particular item at this point, look at this line. From here to here, it's a straight line, isn't it? From here to here, it's a straight line, right? And so I'm saying that hexadecane has a phase shift at 291 degrees Kelvin, and the thermal conductivity drops significantly. And how do I predict that thermal conductivity? The same equation. And you know how I did that? I took this point and created a line. And, you know, and it looks fancy. Well, it is fancy, but that's for the University of Notre Dame. Right. This was a professor, and this was a PhD candidate. I don't think he was a PhD candidate, really, truthfully. Good guys, though, really helpphul. But anyways, that's the stuff I'm teaching you today. Well, yeah, I am smart.
You know, if you Google that 10 phase